Today we are going to discuss problem 796C, bank hacking. So let's introduce this problem by explaining an example here, right? Example 2. So we have 7 in the input, which means we have 7 computers here. And we have 7 numbers here. So each of the number denotes the strength of the node, right? So the node 1 has strength of 38. Node 2 has a strength of -29. And then we will have n-1 edges here. So we connect 1 and 2, right? This edge. And we connect 2 and 5, this edge, right? So we are guaranteed to have n-1 edges, which means if we start from any node in this graph, for example, we start from node 1, we can get a tree, right? It doesn't matter which node we choose as the root. We can always get a tree, right? For example, if we choose node 6 as a root, we can also get a tree, right? So the problem here is that we can choose a node, choose any node in the graph, and then its neighbors' strength will increase by 1, right? For example, if we choose node 7, its neighbor will become 39 and 29. And all the other nodes will increase their strength by 2, right? So node 2 will become 27, and node 3 will become 89, and node 4 become 95, node 5 become 41. So we have to calculate the maximum of all these nodes after we choose a root, which in this case is 95, right? So if we choose this node as a starting point, we can get 95. So this problem is asking us to find a root that gives us a minimal end result. So in this case, if we choose 7, the end result is 95. And if we choose node 4 as a start, let's try it again. Its neighbor is increased by 1, right? So it becomes -28. And all the other nodes are increased by 2, which is 41, 89, 30, 53, and 40. So the biggest number here is 93. So the output here is 93 because it is the smallest end result we will get. Right? So how do we solve this problem? We can use dynamic programming, right? So let's see it here. Fij is Fij means if we consider node number 2 and its offsprings, which means these 4 nodes are considered here. if we increase its value by j, right? If ij is the minimal strings, we need to hack node I and all its offsprings, right? So as we can see here, if this node is strings is increased by 1, right? That means its offsprings strings are increased by 2, right? So we got 89, 95, and 41 here, right? So that f21 should equal to 95, right? So here we got a 95 here, right? So these pink labels means that the values of each node, right? So these three values are f4, 0, and this guy is f4, 1, right? This guy is f4, 2, right? So how can we calculate all these f values, right? So we can use deep first search. So start from the root and go all the way down to the bottom, right? So that this guy, if we consider node 4 alone, we can know that if we increase its strings by 0, which means we start from node 4, our minimal strings is 93, right? And if we increase it by 1, its minimal strings is 94, and we increase it by 2, then minimal strings is 95, right? So if we consider this node 2, we can know that f20 is equal to the maximum number of the value itself and all its children's if we increase the strings by 1, right? Which are this one, and this one, right? And we find the maximum value of these numbers, and we can get 94 here. So we get a 94 here, right? And also if we increase the strings of the node by 1, it means we increase the strings of its children by 2, right? So we need to compare this number, this number, and this number plus 1, right? So we get 95 here. So if we calculate all these f values, we can get the tree like this, right? So after we get all these f values, we can use deep first search another time, right? So we can, for example, if we can choose the node 2 as the starting point, what what is the maximum value it will be in this whole graph, right? So this node is going to increase by 0, right? It's a self, and we can get a maximum value from this guy, because all its neighbors are increased by 1, right? And we can get it from this guy and this guy, right? And don't forget, we need to consider its parent as well. So during the deep first search, we need to pass the parent's value along with the recursive call, right? So let it be said, let's look at the code, all right? Let's read the code. Here we go. So let's look at the main function here, right? So first we read n, and then read all the nodes values, right? And then we get all the edges and insert it into the array, right? Then we calculate all these f values. So how do we calculate them? So we run a recursive call. So we pass the current index, right? This is the last index, which is the parent of the current node, right? Then we calculate f0, f1, f2, right? So we calculate all those 3 numbers, and then after we get all these 3 numbers, we run the DFS again, right? This time we also pass the current index and the parent index, right? And we also need to pass on the parent states, right? Because when we choose a node as a starting point, we need to consider all its children's value and also its parents' value, right? So in this way, we can get all the end results when we choose any of the node, right? We can choose each of the node as a starting point and get the end value, and we can record the maximum value in the variable answer, and in the end we can print out the answer, right? So I guess that's it. So this part and this part is a little bit tricky, especially this part. So what I did here is that when I pass on the parent's value, I keep all its children into a set, right? And if we goes into these children, then we record all these nodes' maximum value and pass it into this recursive call, right? So I think take some time here, you will know why I did that. So I guess that's it. Thank you for watching.